Thanks for watching this screencast. The objective of this screencast is learners will be able to graph a quadratic function in vertex form. So we did a whole learning target on graphing quadratic functions, but this one, learning target 14, is more about transformations of quadratic graphs. And as you saw in the Desmos sheet that you played with before you watched this screencast, you were already, I hope, pretty familiar with the idea of using numbers to add and subtract to the function in different ways to shift the graph in 4 directions, left, right, up, and down. And because of that familiarity, I hope it's pretty clear to you why this form of a quadratic function is called vertex form. In this vertex form, f of x equals a times x minus h, that quantity squared, plus k, where a, h, and k are all real numbers, and a is not 0. If a were 0, this whole thing would be gone, and it would just say f of x equals k. It would be a constant function. In this form, the point h comma k is the vertex of the graph. Let's talk about y for a second. This number h here, since it's happening to the x value itself, would shift the vertex of the graph left or right by h units. And in fact, we said back in learning target 5 that shifting left or right, the number added to x kind of did the opposite of what you would expect. So if I actually have like x minus 3, then I'm going to shift the function right 3, which would put the vertex at like x equals 3, you know? So that's why this value h here, whatever h is the x coordinate of the vertex. The value k would be the y coordinate of the vertex. Why would that be? Well, if you add a real number to the function itself, to the x squared function, you're going to shift the graph up or down. So the vertex of the standard x squared quadratic graph at 0, 0, you know, if you make k a 4, would be at 0, 4. If you made k negative 3, then this would say, you know, something something squared minus 3, and the graph of the vertex would have a y coordinate of negative 3 as well. So I hope that this isn't much of a stretch if you were already pretty comfortable with our idea of transformations earlier in the course. Now the last thing to talk about here before we try some examples is a. This number a, if you thought about transformations earlier, we said if you multiply a number by the function, the x squared function, it's going to stretch it vertically, and that's exactly what this does. This a number will multiply every y value by whatever this number happens to be and stretch it, or if a is between 0 and 1, it will compress it, it will shrink it down. If a is negative, it will affect the direction with which the with which the quadratic opens. But that's consistent with what we said previously, just together this year in the course too. The sign of the a term still indicates the direction which the function opens. Here are a couple of quick examples. The instructions say find the vertex and graph the function. Let's look at f of x equals x plus 1 squared plus 2. So if I think about that form that a equals x minus h squared plus k, can you indicate the vertex? The vertex is going to be whatever h is, comma, whatever k is. So the value of h that I need to make this look like x plus 1 is negative 1. Right? Like if it says x minus negative 1, then that would be x plus 1. So h is negative 1. And what's k? K is 2. The vertex of this graph is at negative 1, 2. Okay. Now to graph the function, you guys are already pretty solid at that. What I need to do now is I need to think about maybe the symmetry. Think about that axis of symmetry, which goes vertically through the vertex. Be careful if you start thinking about other points. Don't assume that this number is the y-intercept anymore. In fact, it won't be. If you let x be 0, you would actually get 1 squared plus 2, which is 3. And that will work. Okay? That will work. I also want to suggest to you that there is that pattern for graphing that was discovered in class a couple of weeks ago, that as you work away from the vertex, you can go up each unit. You go 1 unit in the x direction away, you can go up by the odd numbers. So if I want 1 unit away, I can go up 1. 1 more unit away, I can go up 3, both directions, and so forth. So there's a decent sketch of the graph. Take a look here at this example. It says f of x equals -3 times x minus 1 squared. What's the vertex? What's h? What's k? H would be the number you need to put to make this like x minus h squared. So I think in this case, h is 1. There's no k, is there? That means it's 0. Our vertex here is 1, 0. Now this -3 here, the a value, means it's going to open down. And it means that as I work away from the vertex, if I sketch in that axis of symmetry again, I don't need to go down 1 first, I need to go down 3. It's going to stretch the shape of this 3 in the negative direction. And I'll hit this point as well. There's a decent sketch of our graph. Okay, pause the video, see if you can determine the vertex and a general idea of how we would sketch these functions. Panthers, for the example on the left, f of x equals the opposite of x minus 4 squared plus 1. The vertex is at the point 4, 1, which is right there. I know the thing opens up downward because the a term will be negative if I thought about multiplying everything out, or I can just indicate here's a here. A is -1. What that tells me then is that the pattern to graph with is to go down 1, and then down 3, and then down 5. Half of my graph will look like this. The other half will be its mirror image. This way. The vertex of this graph, f of x equals 2 times the quantity x plus 2 squared minus 3, is -2, -3. Right here. This thing opens upward because a is positive. Here's my axis of symmetry. Because the a is 2, instead of working away from the vertex and going up 1 first, I want to go up 2. The next one would be, the next odd number after 1 is 3, so I need to double that. I need to go up 6 now. And I can mirror those to get my shape. Something like that. Oops. Well, we'll go with it. Not an art major, folks. And that. Get accurate points on there and show me the general shape. Try and do a little bit better than I did there. And it will be golden. As always, thanks for watching.